Hey, today I'm showing you how Tachikoma parallelized agent work. So the pattern is called fanout and the idea is simple. You take a query and you split this query into n branches that run in parallel. It's the equivalent of the map, and you bring back the branch together and it's the equivalent of reduce. So it's like map and reduce. Think of a claim split into 8 branch office, all analyzed at the same time. And the clever part of how we are doing the things in Tachikoma, it's because we'll not explore different patterns, but we'll compose between two axes, which is a fanout and collection discipline, and the kernel, which is the compute after we collect all the branch. Each time you are query and you are found out, you will have a trace ID which allow to find out the origin of every event you will encounter across your graph processing. So the first one, the collection discipline. How we bring back the branch, how we found out and we bring back the branch together. So the adjacent join is the most simple one. So you dispatch to an agent into n branch a query, and this agent will run all this query in parallel, and just after the agent you have a hook when the query end up, and it just merge and bring back all these branches together, and you compute. And you make the compute like that. So it's just after the agent. After we have the perfect close at end, the difference, it's kind of adjacent join, but the difference, it is like the collection of all branch can be at another place, not just after the agent. It means like all the branch could have their own life cycle, and they can be joined at one point of your graph process wherever you choose. So it's really interesting in many situations when the dispatch have different meaning. If you have a semantic router that will take some event into these things and other type of event into the other one, and at the end you want to create a report which need different aspects and processing. The second one the third one is the latent pool. So latent pool is interesting because into the last two patterns we are dispatching n branch and we are collecting n branch. The latent one is like a sliding window, and it will continuously waiting for n event into this window collector, and it will run the process of the kernel when this window is full. So you can process continuously. It's not like there are beginning and end. The other one is the ambient multi. So it's kind of perfect, but the difference is you will have different collector at different place inside your graph process. It means like you can have different output strategy, a different outcome at different place, and coming from the same query. After so now we'll start with the kernel, so how it's compute. The second axis, we start really simple, like with append. Append is just the concatenation of all parts. After we have the summary window. So the summary window, it's really interesting when, for example, you want taking care of a context connect to a business need. So you will enrich continuously this context, and summary window will continuously summary all the events. So it's semantic computing. After you have transform, it's kind of the same, but the difference, it is like it is just compute. So it's more the opposite than the same. And after in 4 we have the RLM context. So the RLM context is kind of summary, but imagine like in summary, you just have one agent. RLM context is really suitable when you have a business case that need many data sources and many kind of data, of different data. So you will have multiple agents. It's like summary, it's one of the agent, but now you can have multiple agents for searching, validate the queue, add reference, and they will continuously work on the same context. And after you have OKF, so it's kind of taking the format of wiki of Google for the wiki knowledge base. And the idea it is, instead of put directly the data of a data source or database inside the event, you will put just the schema of the database and an interface, an interaction interface. So the agent will interact with this interface, feed and transform the data directly into the database, and update the schema. We will continue after. So it's allowed to deal efficiency with the database inside your graph process. And after, if you have interest of on the technical implementation, you can go on the website tachikoma.sh, and in the docs you will have this article, and you will have like a different implementation. Also we will explore different composition of collection and kernel, and in which scenario it's the most suitable. So don't hesitate to make me a return if you like it. Bye.